Hey guys, all right, so let's go over your review. If we were in person in class, this review would have been a partner quiz. You'd have been broken up into partners, and you guys would have taken this together as a quiz, and then we would go over it, and then you would correct what you had done wrong over the weekend, and then we would do our quiz. So, but since we're not doing it that way, obviously this year, this is your review. So you've had a chance to work on it and attempt each of these problems. And now I am here going over it in this video for you guys so that you guys are prepared to study for this quiz and be ready and ace it and totally make me proud. All right, so number one, it says, what is the limit as h approaches 0 of sine of x plus h minus sine of x all over h? Well, this should look very familiar. Yeah, there's signs in there, but it is using the definition of derivative. This is the little formula we've used to find the derivative. We called it slope for the longest time before we officially called it derivative. And you started learning this at the end of Enhanced Math 3 last school year. So you should recognize that. So if this is representing the derivative, then this means that f of x must be equal to the sine of x, which means that the derivative of the sine of x is, well, we know this is one of those identities that we learned, it's cosine of x. Okay, so it's just one of those that you have to remember. So first of all, you have to know that this is the definition of derivative, similar to the one that was on the warm-ups. The one on the warm-up used the instantaneous velocity formula for derivative for slope. Where is it? It was your number 3 from the warm-up. Use instantaneous velocity. But remember, I told you it could come in this format or it could come in this format. You have to recognize that both are representing the derivative. Okay? All right. And then number 2, it says find the, I know it's kind of hard to see, it says the following. All right, so the first one, done. Number 2, that word says the following. So find the following, and we're given a graph of f of x. I know it's kind of hard to see. You can see the dash mark there, so you know that this must be the x-axis, and you can faintly see this one, so this must be the y-axis. Okay, and we need to find the following. And I notice that the first thing it says there in Roman numeral 1 is to find the limit as x approaches negative infinity of f prime of x. Well, this graph is of f of x. So that means we're going to need to draw a graph of f prime of x. So I'm going to need the space down here for number 3. So I'm going to draw the graph next to the original. Okay, so we'll have a -2, -4, +2, +4, just like we have on the original graph. And let's label this. This will be f prime of x. Okay. And so the first thing we look at when we're looking at an original graph are where the horizontal tangents are. We have a horizontal tangent over here at -2, so that means the slope is 0 at -2. And then we have a horizontal tangent right here. It looks like right before 0. So right before 0, I'll have another slope of 0. And then over here, another horizontal tangent looks like it's at 2. And then right here, a horizontal tangent right at 4. Okay. All right, so now I know that from left to right, right here, the tangent line against this part of the curve would have a positive slope. Okay, and then it comes around this point here where it flattens out, so it's going to turn, and then it gets to a negative slope. So to go from positive to negative means that this is going to be a minimum, or it's going to look like this. So we're coming down with above the graph, these are positive slopes, so positive slopes all the way to 2. Okay, and then on this side we have negative slopes, so we're going to dip down under the negative side. But then at this point right here where it flattens out again, it's going to turn around and turn to a positive slope again. So I'm going to be negative and then hit that point, and now it's positive for a while. And then at 2, it flattens out again, okay? And so that means that it's going to be positive and then come back down at 2. And then we are down at a negative slope, so we're going to be below the x-axis again. And now we turn around and hit the 4, and then we're back to being positive again. So it's like a W. Okay. All right, so once you have that, now we can answer those questions. So let's take a look at number 1, room numeral 1. As x approaches negative infinity, so it's going to the left, f prime of f prime of x, we are going up. So it's going up to positive infinity. And we know when the limit approaches positive infinity, it has no limit, or the limit does not exist. DNE. Roman numeral 2, the limit as x approaches negative infinity of f of x. So the original graph, we're going towards negative infinity. And on the original graph, it's going down, 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 down to infinity. So that means down to negative infinity, which we know when it approaches infinity, the limit does not exist. DNE. The limit as x approaches 2 of f prime of x. So we're looking at the derivative graph and we're approaching a positive 2. Well, as we are approaching 2, that x value there has a y value of 0. So the limit is 0. And then Roman numeral 4, true or false, f prime of x is greater than 0 for all x greater than 4. F prime, remember, this means the slope. The slopes greater than 0 means the slopes that are positive for all x values greater than 4. Well, let's look at our derivative graph, and x values greater than 4, so it would be to the right. Well, the slopes there are going to be positive because they're all going to be above the x-axis going to infinity. So yeah, that's true. All right, number 3, it says write the equation of the piecewise function below, just like the warm-up. So you're obviously going to have a question like this. This is going to be similar to the FRQ. Okay, so another FRQ practice here. All right, we've got 3 pieces. So let's take a look at the first piece. It's linear. And let's see if we can find a slope. So it looks like the y's are counting by 2. So halfway between 0 and 2 would be a 1. This would be a 3, 5, and so on. Okay. But it's counting the normal counting numbers 1, 2, 3, 4, 5, 6 along the x's. So this one's -1, -3. Okay. So it looks like we're going up 1 over 1. Up 1 over 1. It looks like it's doing that throughout. So that means that the slope is 1. So my mx part of that equation is just going to be a 1x. And where would it cross through the y-axis? So if we go up 1 over 1 one more time, we will hit the y-axis at a positive 2. So it's plus 2. And these are for x's that are, it's a solid dot there, so less than or equal to -1. Okay. All right. Next piece, this little parabola looking thing, part of a parabola. Well, it looks like the vertex is at 0, 0, so the parent function did not shift left, right, or up or down. And it looks like it has a next point up 1 over 1, so the amplitude is just a 1. So it's just x squared. It's just our parent function. Okay, the x's that we're using, though, are from -1 to +2, and there's a closed point there at the 2. But we already used the first part of the first piece as equal to -1. So that means we can't equal -1 this time. It's just going to be less than negative, or -1 less than x, and then less than or equal to the 2. Okay. All right, and then the last piece, I see that it's an open point there at 2, and it's a horizontal line. And that horizontal line is at y equals 3. So it's just 3. And it's for points that are greater than 2, to the right of 2. So x greater than 2. Okay, so there's our piecewise function. Hopefully those are getting easier by now. All right, number 4, it says to identify a value of x at which the function is continuous but not differentiable. Give a reason for your answer. Well, we know that on our graph, we have a corner right here, and we know at corners, they are continuous but not differentiable. The derivative will not exist there because the slopes are different on either side. So I'm going to put corner. But we have to say more than just that it's a corner. Okay, just like the warm-up. So we can say if x equals, what's the x value there? It's a -1. If x equals -1, comma, then f of x is continuous since, we have to say that f of -1 is defined, and we can say the limit as x approaches -1 from the left of f of x equals the limit as x approaches -1 from the right of f of x, which equals where it is defined, f of -1, comma. So we talked about the continuous part. Now let's talk about the non-differentiable part. So we got to say, but not differentiable since the limit as x approaches -1 from the left of f prime of x does not equal the limit as x approaches -1 from the right of f prime of x. Because remember, differentiable means that we are talking about the derivatives, the slopes. Okay. All right, so that answers number 4, just like the warm-up. Number 5, it says to use your equation to show that the graph above is continuous at x equals -1. So we stated it was continuous up here, and we stated mathematically why, but now we need to show it. So that means we need to take the points where x is -1, or the pieces, and they're right here, x plus 2 and x squared. We need to set them equal to each other and plug in that x value of -1. So plugging in a -1 for x, I'll have -1 plus 2 equals, plug in the -1 for x, -1 squared. Let me zoom in because I'm writing really small. Okay, -1 plus 2 is 1. -1 squared is 1. It works. So we just showed that it is continuous. Okay. Now, number 6 goes on to a separate problem, but let's take this further, just like in the warm-up. So what if it was asking how to show if it's not differentiable? So how to show not differentiable. So I'm going to put not diff. Okay, oops, you guys can't see. How to show that it's not differentiable. Well, just like in the warm-ups, that means we have to find the derivative of just those two pieces. So let's find f prime of x. So the derivative of x plus 2 would just be a 1, where x is less than or equal to -1. And then the derivative of x squared would be a 2x at -1 less than x less than or equal to 2. Okay? And then we set these equal and plug in the -1 for x. So this one's a 1, so there's nothing to plug in. So 1, and it should not equal 2 times -1, and it doesn't. 1 does not equal a -2. So check. That would be how to show if it's not differentiable. So to show continuous or not continuous, you set equations equal. And to show differentiable or not differentiable, you set equations equal, but the derivative equations. regular equations for continuous, derivative equations for differentiable. Okay, number 6. It says, write the equation of the tangent line to y equals negative x squared plus 3x at x equals negative 2. So since we're asked to find the equation of the tangent line, that means that we need to find the slope of the tangent line, which means we need to find a derivative. Okay, so we're going to take the derivative of y. Oops, I did it way over there. Okay, y prime equals, if I drop down that 2 exponent, it'll be a negative 2x and then plus 3. Okay, and now I need to figure out, well, what would the slope be if x is negative 2? So we're going to plug in that x value. So negative 2 times negative 2 plus 3. That would be 4 plus 3, which equals 7. So the slope is 7. Okay, so now let's take that slope and let's write our equation. So we'll have t of x equals 7 times x. Now, since the x value we're at is a negative 2, that means it's going to change this to a plus 2, because minus a negative number. And then I need the y value. So to find the y value, we need to plug it into the original equation. So y is going to equal, oh, there's a negative out front, negative 2 squared. Negative 2 squared is 4, but there's a negative out front, so it's a negative 4. So it's plus a negative 4. Okay, let's simplify that out. Oh, you know what? It's not a negative 4. I messed up. I forgot the plus 3x. So negative 4 plus 3 times negative 2. My bad. So negative 4, and then 3 times negative 2 is negative 6. So this is a negative 10. So I'm actually adding a negative 10. Okay. All right. So let's simplify that out. So I'll have t of x equals, distribute out the 7, 7x plus 14 minus 10. So t of x equals 7x plus 4. And there it is. All right. Number 7, it says, given the derivative, sketch a graph of the original. So this is the derivative graph, f prime of x. This needs to be the original, so f of x. Okay, so it's just like the warm-ups. All right, so this is the derivative graph this time, not the original. So I know that since these are all above the x-axis, all the slopes are positive. Positive, positive. Okay, I know that since we're touching the x-axis at 4, that means that there must be a slope of 0 here. So there's going to be a turn right here. But how can the turn be when it's increasing and then it flattens out and then increasing? Well, it's not going to be an upward or downward facing U. So it's got to be, we're increasing, it flattens out, and then increasing. So it's got to be a shelf. Okay, so let's just make sure that our shelf is there at an x value of positive 4. So we're increasing, 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 and then we flatten out at 4, and then increase and increase and increase. Just make sure that it looks like I could have done a little bit better to make that flatter. Just make sure that you have your horizontal tangent right there at x equals 4. And there's the original. All right, that's everything, you guys. I hope that you are studying and you're understanding these, and you'll be well prepared for this quiz. I'm expecting good things. Study, study, study. I'll see you guys on Tuesday.